this video, I'll start a new topic called analog and digital quantities. Analog and digital quantities. In some cases, the word quantities will be replaced with signals or electronics or technology to read as analog and digital signals or analog and digital electronics or analog and digital technologies. It's one and the same thing. So I'll start with analog. Start with analog signals. I'll prefer to use the word signals. So what are analog quantities or analog signals? So analog signals or technologies, these are signals. These are signals that use continuous or several values. That use continuous or several values. Or several values. So analog technologies use continuous or several values. What does it mean to use continuous or several values? Okay, so I'll give a comparison of digital electronics. So in digital electronics, we only use two numbers to make any calculation, to list anything, to display anything, to process any form of information, which is 0 and 1. So in digital electronics, all information that you have to process will just be handled or be processed using 0 and 1. But yet, in analog signals, you're going to be processing information using different or multiple, a plethora of numbers. You can go from 0 to a billion. You can go from a billion to a trillion just to process information. So that means in analog signals, you're not limited to any set of numbers, but you're using what? Continuous values. So that means when you're using analog signals, you can use different types of number systems just to be able to process what? To process information. A good example of this is what? Is temperature. So when it comes to temperature, I'll give a diagram. Okay, that's why I say this side you have temperature in degrees Celsius, this side you have time as day, or as days. Okay, so you have one, let's say two, second day, third, then you got fifth. Let's say it's 75, okay, 80, running all the way up to what? Up to 100 as an example. So if you want to read temperature sweep this through this way. From there, then it drops like this. So let's say this temperature had to transition from, let's say, 70 degrees Celsius to 80 what? To 80 degrees Celsius. What is going to happen is that for temperature to go from 70 degrees Celsius to 80 degrees Celsius or Fahrenheit, what's going to happen is that there will be a count from 70 until 8. You're going to go from 70, 70.1, 70.2, 70.3, 70.3, 70.4, 71, 72, 73, 74 until you reach what? You reach 80. And if you look at that, that is not one number system. You have used fractions, you have used whole numbers, you have used decimal, you have used octo number system all in one place just to process information. But yet in digital electronics, you only use what? Two numbers. So this is what it means to say that in analog signals, there will be what? There will be continuous or several values that use to do what? To process information. So now if we understand that, we are going to look at the types of what? The types of analog signals. Types of analog signals. Types of analog signals. What are the two types of analog signals? The first one is analog electronic systems. Analog electronic systems. Analog electronic system. In an analog electronic system, these types of systems are implemented to use strictly only analog values. Okay? They use only analog values. They use only analog values. They use only analog values. So in this type of a system, all the calculations, all the components will be using what? Analog values or analog technologies and nothing else. So a good example of this is a public address system. Public address system. So in a public address system, you're going to have a microphone, as an example. So a microphone is linked to a linear amplifier. A linear amplifier, the linear amplifier is connected to a megaphone or a speaker. The speaker as such. So now here you're going to have what? Sound waves. So sound waves are not in digital. They're actually in analog because they use several values. Okay, so you have sound waves. So you pick sound waves. Here they are. When they come here, an amplifier is going to expand the sound wave, and then the sound wave will now be projected to the speaker, and people are able to hear what someone is saying through the microphone. So if you look at the public address system, entirely the microphone is an analog, the linear amplifier amplifies the analog signals, then the speaker also is able to project out the analog signals. So that is how an analog electronic system looks like. It uses completely only analog values. The second type of analog system we're going to look at is an analog and digital system. Analog and digital electronic system. Analog and digital electronic system. An analog and digital system uses both analog and digital values. A good example of an analog and digital system would be a compact disc player. So the compact disc player, it has a CD drive. So I have a CD drive there. So remember, a CD drive is going to be using a compact disc which stores information in binary. Then the information will be transmitted through to a DAC. So a DAC simply stands for digital to analog. Stands for digital to analog converter. So it takes digital signals and converts them to what? To analog. Then this will be pushed through an amplifier. So an amplifier will be connected to a speaker. Right. So information will come here in binary. Okay, information will come here in binary. Then it will be converted to what? To analog, and then to be expanded and to pushed out through what? Through the speaker. So this is how an analog and digital electronic system works. It uses both analog and digital signals, or analog and digital what? Values to process information.